Hey guys, some people requested a video for 9 and on, the problems there. I already did a video out on the rabbits, so check that out. It's on Manage Back. For number 9, we're trying to do something else with the data, and so usually you can click on that link, but the link seemed to be broken, so I sent you a link in your email. If you click on that, it should take you to
Yeah, so
this, and you can just
I'm
copy this
showing you
data.
something about
I
shared
just select it
screen. Can you see my screen?
and say Control C, and then you can come here, and I'm not going to delete that, makes it easier, and Control V and paste it. And so here's,
Oh yeah,
you
the
can see here's
certificate.
the
So when you
Fox
go
data,
up,
right?
just
And we're
tap
trying to
on
model
the
it
again the
based on what it
column
says
three.
here, right? Y1,
Okay,
this whole
just
thing. I wonder
tap
if I
on
can
the
just copy
phone and
this and
then
paste it in
next to
here.
the three,
Might make it
dots on the
easier.
bottom, and then you go to
Yeah, look at that. And
share,
then
and then you select
this one,
the
yeah, this one
screen.
hasn't been working.
Share
I'm
your
not sure
screen,
what
or you want to
the
share a
deal with this is.
photo,
Hold on one second.
document.
Okay, so what's happening here is this is actually creating a function because the sine graph oscillates, goes up and down so
Yeah,
much, it can actually get it to
go to
pass
the
through
middle
every
or
single
center.
point. But it's obviously not a good model because it's
So
not
I'm gonna
showing what
press
we want it
share
to show,
again,
right?
and
So
then you start
we're actually
clicking
going to
on
modify this, and we know that
messages,
the
and then you
period
go
for
to
this
parents or something.
is
Press this
determined by
button.
b, right?
I
And
should
so
do
what we
this.
want to think is like, okay, what should the period be for this? And what we kind of talked about in the rabbit problem, but this is going to vary based on in the year, right? The cycle of the year, right? In winter, the population might go down, and in summer, the population might go up. So
So
the
much
period should be
harder. It's
12
like, oh, I
months,
know.
right? Remember this number over here, the b value is always given by 360
Yeah.
divided by b, and we're saying 360 divided by b should be 12.
Yeah.
So you could set up a little equation and say 360 over b equals
Okay.
12, and you could solve that for b, right? So that's just 360 over 12
I'm
equals
gonna shoot
b.
me a
So
text.
360
Yeah.
divided by 12, not 260. 360 is 30. So this number
Okay.
here should
So like
actually be
how are your
30.
kids with their
And then you can see
classes?
that that's going to give us the correct period. So in this case, the regression model didn't quite work for us, right? So this is a case where like technology is not going to be perfect. You need to do a little bit of thinking to think like, what should this number here actually be? And again, it's 360 over 12 because there's 12 months in a year, right? Okay, so the next one is once we have that model, we go to the next slide, and we're looking at find and interpret the midline, amplitude, and period. So the midline is right here in the middle, right? It was in this case, the midline was the k value, which the k value here is 110, right? So that k value represents, so the midline
Yeah. Yeah.
is 110.
So
This
I'm gonna
represents the
put this
average
somewhere.
population
I don't know if my offer that
of
later. It's
uh,
actually on video.
average population of foxes throughout the year. The amplitude, which you can come back here, amplitude in this case is negative 58. So you might want to think, why negative
Yeah.
58? The 58 represents, so the amplitude, the 58 represents the deviation, the maximum deviation from the average,
Yeah.
which also then determines the maximum population, the minimum population, right? If the midline is 110 and the amplitude is 58, then the maximum population should be 168 and the minimum population should
Yeah,
be
you can
110
tell.
minus
No, he's
58.
in Malaysia.
Um,
Yeah, they
and then the
like
negative sign on there just means that we started by going down, right? Like
so
usually the sine graph starts by going up. In this case, it started by going down. And then the period or cycle, we talked about that. That's just like 1 year, right? So it was 30 because, the period
yeah, I know.
was 360 over 12, and the 12 was there because of 12 months in a year, right? So that's what that one would be, right? Next one would be doing the temperatures in Temecula. I'm gonna go ahead and just get something from another student here
Yeah,
so we can look
because
at
if
that.
they stay, then they would have to pay their salary, their
So
country.
here's one for that.
We don't
Uh,
have that here.
you can see if you go to this website, enter the data, you get this, and then you just use that same sine model. In this case, it actually gives us
No,
a
we don't
pretty
even
decent
have that.
model for it. And the midline is 79.5. Again, we're talking about temperatures. So the midline is going to be our average temperature,
No,
average high
no,
temperature,
no,
right? So careful there. It's average
we
high
don't have
temperature.
any tax.
The
It's
amplitude
based on the
is
number of
negative
people
11.6. In
living
this case,
in
just
our
think about the
country.
11.6. That
Because
means
the
from
economy is based.
79.5, we could go a maximum of 11.6 above the average and a minimum of 11.6 below the average. And the negative, again, just means it starts out going negative. that number, that might depend if he changes h value to something else. And the period is 32.8. That's how long it takes. That's the b value. So the period's not actually 32.8, right? The b value is 32.8. So then remember that. Let me get to not a physics screen here, but hold on. Let me get to something. Okay, so the b value is 32.8, but remember that the period is given by 360 over b. Wow, this pen is really not working. 360 over b. Come on. Which means, in this case, our b value is 32.8, right? So this would be 32.8. And if you do 360 over 32.8, do that here, 360 over 32.8, you get something really close to, you get 11, which, and that's a little bit weird in this case, but what do you think the period should be? Well, the period actually should be 12 if you think about it logically. So if you wanted to actually change this again to that 30, you could. Let's see what happens if we change this to 30. It's still pretty accurate, but the model's just fitting it directly. So the period is actually about 11. Next one, again, you go to this website and you type in the function and you this is again the temperatures in Temecula. You find the model, you find the midline amplitude period. Oh, we already did this one. Next one, this is the low temperatures, so you do the same thing. In this case, we get a midline of 10.6, which is saying the average temperature is 10.6 degrees. The amplitude is 6, meaning it's going to vary. The lows are going to vary by 6 each month. And again, the period, this is the b value. The period is actually 360 divided by 31.8, right? And then it asks you to interpret it. I'm not sure why it's doing these things twice. What's the significance of the midline? The midline is the average low temperature throughout the year, the average low temperature, right? What's the significance of amplitude in context of the problem? The amplitude is the deviation from the average low, right? So like the highest it can go from the average low, the lowest it can go from the average low, right? And then which of these cities have the highest midline for low temperatures? So it's which would have the highest average temperature? Honolulu would have the highest average temperature, right? Because it's always hot, whereas it doesn't ever get cold, right? Juneau, Alaska, so we're talking about low temperatures, right? Juneau, Alaska would have very low temperatures, and then San Diego would, kind of warmer there, but not as warm as Hawaii. And New York would have some lows, but in the summer it doesn't get that cold in New York, right? And then the next one is which of these cities would have the highest amplitude? Remember, amplitude is deviation from the midline, right? So deviation from the average temperature. So which one? So Honolulu, Hawaii stays very warm all year long, right? So its amplitude is going to be very small because the deviation from the average temperature is not a lot. Juneau, Alaska gets really, really cold, and then in the summer it still gets very cold, but not as cold. So there might be a lot of deviation there. San Diego also doesn't have a lot of deviation in their winter. New York might be a better answer than Juneau. It's kind of up for debate because in New York it gets quite warm during the summertime. But I would say the further away you get from the equator, the larger amplitude you would end up getting because you're getting to more extreme temperatures, right? Higher highs and lower lows. So I think Juneau, Alaska is a good example. And then on the next one, this is a real tricky one. You can, as you can see, like it goes, it's not like a perfect sine graph, right? And so you'd have to try to figure out, this is pretty good what we have here, but you can see it's still not perfect because sometimes it goes a little bit higher, and sometimes it goes a little bit lower. So there are some things we could do to make it even better, but you don't really need to know that for this course. Maybe I'll come back at the end of the video to show you that, so you don't have to watch me do it right now. And then the last one is just the Ferris wheel. Just remember, for any wheel type of problem, wherever the center of the wheel is, that's your midline, right? Because the whole thing's centered around this, right? Your height gets above that center and below that center. So the midline's always the y-coordinate of the center, which in this case is 50, right? So that should go here. The radius of the wheel is always the amplitude. So you can see in this direction, the middle is 50. The highest deviation from 50, it goes up to 90. So from 50 to 90, that's a distance of 40. So your amplitude should be 40. Again, the negative just signifies that it goes down first instead of up first. And then the period here, remember, this is the b value, this is not the period. The period would be how long does it take me to make one full revolution. And so that's a little bit hard to see just given based on what we have in this particular video. Let's say we go a little bit higher than this. Let's see if we can have it go one full rotation, and let's see how long it takes, right? So when we start there. So we want to know like how much time, what value do I need for it to go all the way around, right? So I'm just going to drag it all the way around is right about there. So it takes me about, it's not quite enough. Let's go a little bit farther. There you go, that's a good one. It takes me about 1150 of these time, which is not really seconds in this case, but it takes me 1150 to get to there, right? So remember that the period equals 360 over b. In this case, this is 1150. And so 1150 b equals 360. Therefore, b equals 360 over 1150, right? 360 over 1150. So if I do that down here, 360 divided by 1150, we get 0.313, right? So we could actually maybe modify this a little bit better, 0.313, and maybe it'll even fit even better then, right? Let's go back and see. And I think we should change the change this so we can see farther. Right, you can see it follows that graph really well like that because we chose the period to be perfect, right? We calculated it using something that we know about it. All right, so I hope this helps. Please reach out if you do have more questions. Oh yeah, I was gonna go back and do this problem back here, see if we could find a better fit for it. So let me just get rid of this stuff real quick. You see this fits pretty well. What we could do is we could add like another sine function. Over here. So it's a struggle for me too, but notice that just what I've been trying to do is just, you can add another sine function here and maybe another sine function here. And I just added sliders for like the period because the amplitude and the midline are the same, right? Still -3. But then like there's like sine functions within sine functions, right? So then I can just play around with these things. You can see, you know, how this guy's kind of moving it up and down like that. Actually, that one just be 0 and it's better. And then this one is kind of changing the overall period of all these things. And this b value kind of determines the shape of all of them as you go. And so you can kind of mess with this and it gets it to fit. And you know, obviously you could do like if you had the data points, you could just do like a regression. But again, that's not really necessary for you to know. It's just a matter of playing around with like, you can see there's peaks within peaks. So you need more than one sine function in there to get it. So if you want to play around with it, see if you can figure it out.